We spent a lot of time in this chapter talking about angles, and now we're going to move into talking about lines and how to find the slope of a line. A lot of this will be reviewed from algebra. So first let's talk about slope. So what is slope? Slope is the measure of the steepness of a line, and in terms of a formula, you've probably remembered seeing this before. It's finding rise over run, or in other words, the change in y over the change in x, or if you have actual points to work with, that's y2 minus y1 over x2 minus x1. Now there are 4 different cases of slope that you may find. First, you might have a positive slope that rises from left to right, so for example line K. Or you can have a negative slope, so that falls if you're going from left to right, so that would be line J. You could have zero slope. That simply means that you have a horizontal line, which in this case is line L. Or you can have an undefined slope, which is simply a vertical line, and in this case that would be line N. Alright, take a look at example 1. Find the slope of line A and D. Now let's start by looking at line A. So we see that line A goes through the points 6, 4 and 8, 2. I'm going to use those points to find the slope. So the slope, remember, is going to be y2 minus y1 over x2 minus x1. Now it doesn't matter which one you make x1, y1 and which one you make x2, y2, as long as you're consistent. So let's say, for example, that I make x1, y1 the 8, 2 and x2, y2 6, 4. Then, when I use this formula, I'll have 4 minus 2 over 6 minus 8, and simplifying that, we have 2 over negative 2, which is equal to negative 1. So the slope of line A is negative 1. Alright, now let's find the slope of line D. Now, while I know that it is a vertical line, and that must mean it has an undefined slope, let's see how we actually get to that. So you can see the 2 points that D goes through, 6, 4 and 6, 0. Let's go ahead and apply the formula. So y2 minus y1, I have 4 minus 0, and then x2 minus x1, I have 6 minus 6. That leaves me with 4 over 0. And since we have a 0 in the denominator, we have an undefined value here, which means that the slope of line D is undefined. Next, we have some postulates. So the first has to do with slopes of parallel lines. So in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. Now, any 2 vertical lines are going to be parallel to each other. So what this is saying is simply, if you have 2 non-vertical lines, they have the same slope. If you have 2 lines that have the same slope, then they're parallel. And vertical lines, because they have an undefined slope, we'll be able to say that they are parallel to each other because that's the only way to get an undefined slope is when they are vertical. Okay, next we have slopes of perpendicular lines. Now, in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. In other words, you have negative reciprocals or opposite reciprocals. Now, horizontal and vertical lines will be perpendicular to each other. Now, this is the one case where you won't be able to get that product because you would be multiplying 0 by an undefined term. So just know that if you have one line that is a slope of 0 and another line that has an undefined slope, they are going to be perpendicular to one another. Alright, look at example 2. Find the slope of each line. Which lines are parallel? So we have lines K1, K2, and K3. They all look like they could be parallel to each other, but the only way we can tell for sure is if we find the slope of each line. So let's start by finding the slope of k1, which goes through negative 2, 4 and negative 3, 0. So this is going to be 0 minus 4 over negative 3 minus negative 2. So that's negative 4 over negative 1, which is equal to 4. All right, let's move on to k2. That goes through 4, 5 and 3, 1. So this is going to be 1 minus 5 over 3 minus 4, which is negative 4 over negative 1, which is equal to positive 4. Next, find the slope of k3, which goes through 6, 3 and 5, negative 2, and we'll do the same thing again. So we have negative 2 minus 3 over 5 minus 6. So this is negative 5 over negative 1, which is equal to 5. Now, the question was which lines are parallel. So only the lines that have the same slope are parallel to each other. So in this case, k1 and k2 have the same slope, so we can say those two are parallel to each other, while k3 has a slope of 5, which is different from both, so k3 is not parallel to any of the other lines. Okay, take a look at example 3. Draw a perpendicular line. So line H passes through 3, 0 and 7, 6. Graph the line perpendicular to H that passes through the point 2, 5. All right, the first thing we need to do is to figure out what the slope of H is. So to do this, we're going to find 6 minus 0 over 7 minus 3, which is 6 over 4, and we can simplify that to 3 over 2. So now we know the slope of line H is 3 halves, and we need to graph the line that's perpendicular to H that passes through the point 2, 5. So here's what we're going to do. We are going to need to find the slope of a perpendicular line, which means it must be the opposite reciprocal of the slope of line H. So if the slope of line H is 3 halves, then the slope of the line perpendicular to that is negative 2/3. So now that you have that, now we can try to draw this perpendicular line. We're going to go ahead and use rise over run to draw the line. Now, since we know that line H passes through 3, 0 and 7, 6, I'm going to go ahead and put those points in at 3, 0, 7, 6 and draw line H. Now I need to graph the line that's perpendicular to H. Now I know the slope of that line, and I know that it passes through the point 2, 5. So I'm going to find 2, 5, and now I'm going to use the slope to find another point. So since the slope of this line is negative 2/3, I'm going to go down 2 and to the right 3. And then down 2 and to the right 3 again, and that is going to be the graph of the line that is perpendicular to H that also goes through the point 2, 5. All right, the last example. A skydiver made jumps with 3 parachutes. The graph shows the height of the skydiver from the time the parachute opened to the time of the landing for each jump. Which statement is true? A, the parachute opened at the same height in jumps A and B. B, the parachute was open for the same amount of time in jumps B and C. C, the skydiver descended at the same rate in jumps A and B. Or D, the skydiver descended at the same rate in jumps A and C. Well, let's go through each of these statements. The parachute opened at the same height in jumps A and B. You can see at jumps A and B, the height for A was somewhere between 3,000 and 4,000, maybe around 3,500 feet. Whereas B looks like it's at a height of 5,000 feet. So A is not the right answer. Next, we have the parachute was open for the same amount of time in jumps B and C. Now for B and C, if you look along your x-axis, which shows you the amount of time, it looks like B was open just under 4 minutes, but C was open for a little bit more than 5 minutes. So B is not our answer. All right, C, the skydiver descended at the same rate in jumps A and B. Now if you see the word rate, that means you're looking at the slope. So looking at jumps A and B, we can see that those two lines are not parallel to each other because it looks like they actually do cross right along the x-axis. Choice D, the skydiver descended at the same rate in jumps A and C. Again, you're looking to see the slopes. Now, in this one, it does in fact look like lines A and C, jumps A and C, have the same slope. So the correct answer here is D.